Hey guys, this is my lab 2 report on lines of a charge. So the purposes of this lab was to essentially redo the computational model from lab 1, and instead of treating the tape as a point charge, we treated the charge as if it was evenly distributed throughout the entire tape. Obviously, when we adjusted this, the computational models would give us different magnitudes of charge for the tape, and then we could compare and see which results were more accurate. In terms of the preview results, from the estimated charge, we get 2.14 times 10 to the negative eighth, and then using the estimated charge, we were able to calculate the magnitude of forces on the tape. Since this was an estimated charge, we later adjusted it so that the forces were equal since the tape was in equilibrium and floating. However, just going off the estimated charge right now, these were the values we got. In terms of the principles used within the lab, since we had a floating object, force due to gravity was obviously used. We used Coulomb's law. And then we used the electric field, but instead for a point charge, we used it for a rod. So the electric field equation was different. And then by knowing the relationship between electric force and electric fields, we can then take the electric field equation and times it by Q to get this equation over here, which is equal to the electric force on the tape as a rod. By then setting that equal to gravity, since it would be in equilibrium as the tape is floating, we can then find Q and get an estimate of Q to plug into our computational model. And the estimate we got was 2.14 times 10 to the negative eighth. So for a recap of lab 1, since we didn't actually do an experiment this week, but it was all computational work, we really just reused our data collected from lab 1. So the length of the tape used was 8 inches, which converted to meters is 0.2302. And then since the mass of the tape was 2 times 10 to the negative 3 about kilograms, and then the separation distance was 0.02 meters. The system was the floating tape, and then the surroundings were the earth and the tape being held. So in terms of the coding, obviously, as I said before, these were the magnitudes of the forces we got using our estimated charge, and we can see that the instances of how many charges we had distributed across it in the next slide. But in terms of the actual coding, we have our constants here, the mass, the estimated charge used, and then we have the adjusted charge used, but I'll get into that later, the separation distance, and then we have the function for an electric field of a point charge, which we then would integrate as many times as we wanted to assume the charge being evenly distributed across the tape. So as I said last time, the instances of the point charge that we use was up to us. The more you integrate it, though, the more accurate it is. So I set mine to 100 just to be the most accurate. This was all scaling, and then this is actually getting into like calculating and integrating the charge to get our actual values out. And then at the bottom is just more scaling and like knowing the axis of the arrows. So in terms of assumptions, we did ignore air resistance because there wasn't a moving object moving fast enough in the air to where it would disrupt our forces being used. In terms of treating the tape as a point charge, we obviously did not assume that, since the point of this lab was to assume that the tape had a charge evenly distributed throughout it, and this was rather the point of lab 1. And then, like I just said, we did assume that the charge had an evenly distributed charge throughout it. Obviously, because that was the purpose of this lab. So in terms of the results, as I said and showed the calculations for, our estimated charge was 2.14 times 10 to the eighth, and it gives us a magnitude of electric force at 1.85 times 10 to the negative 3, and gravitational force at 1.99 times 10 to the negative 3. Obviously, since the floating tape is in equilibrium, these forces should be equal theoretically. So going through trial and error, we were able to get down to this charge as the estimated charge, and once we plug that in, as you can see here with the values and to the right, both the forces would equal 1.99 times 10 to the negative 3. So this is honestly probably a more accurate estimated charge than the one calculated above. So in terms of comparing the models, obviously we can see that from our line charge model, the adjusted one, we get 2.22 times 10 to the negative eighth. And from our point charge model from last week, we got 9.4 times 10 to the negative ninth. So our line charge predicted this to be 2.36 times larger than our point charge model. So there's obviously a discrepancy in the magnitude between them. And these estimates really differ just because of how we're considering the charge and the tape. So obviously considering it as a single point charge versus essentially as many point charges and we integrate it multiple times over again, we're going to get more accurate results and thus a different magnitude, since it's just completely different math. The line charge model is more accurate since the tape more resembles a rod-like structure with the charge distributed across it rather than a single point charge. And that's it.